Chapter 3, Mechanisms. How does evolution work? First of all, evolution works on populations, not individuals. So if you work out and get really fit, socialize and make a bunch of friends, then she said, "Hey, I got a leaf. Maybe next season." And you study really hard and get very smart. Are you evolving? Are you adapting to your environment? You might maximize your genetic potential to become a sharper, better-looking giraffe, but in terms of evolution, the answer is no, because you, an individual, do not evolve or adapt. Populations evolve, and populations adapt over generations. Now, a population is a localized group of individuals that belong to the same biological species. This means they can interbreed and produce fertile offspring. Also, populations are kind of a relative concept, meaning it depends on what you're looking at and how closely you're zooming in. You might be comparing two giraffe populations within one region in Africa, or you could be comparing all the giraffes in that region with all the giraffes in another region, or you might even be observing all the interbreeding giraffes in Africa and comparing them to a population of an entirely different species, like, say, the population of Homo sapiens in your city, country, or planet. But how do populations evolve and adapt? Well, there are a few ways. Let's say we have a population of giraffes, with some males and some females. The females are watching the males eat leaves off a tree, and in this activity we can see some variation in traits. Specifically, there's variation in neck length. In fact, we see 3 different phenotypes of neck length in the males. James has a very long neck and can easily reach the nutrient-rich leaves on the treetops. Sam has an average length neck and can get just enough leaves to get by. Ben, however, has a very short neck and can barely get a leaf. This means that in this environment, James is the fittest individual for getting enough nutritious leaves to live long enough to reproduce. So this kind of competition, in this case for food, is one environmental factor in something called natural selection. Natural selection is the differential success in the reproduction of different phenotypes, like the 3 giraffes, resulting from the interaction of the organisms with their environment. Now, natural selection causes the population to adapt because the next generation will likely look more like James, with longer necks. Another type of natural selection is called sexual selection. Sexual selection is natural selection for mating success. There's intersexual selection, where members of one sex are more choosy for members of the opposite sex. And then there's intrasexual selection, or competition among members of one sex.
Girl, look at that neck. James is so fine. He can just have my babies.
That's right. No necking with the ladies. Got it? They're mine. But not all factors in an environment favor the reproductive success of one particular phenotype. Predation is another factor in natural selection, and often in nature it can go against sexual selection. Huh? Who's there? Yeah, your neck looks the best to me too, James. And I can see it a mile away.
Okay, I guess Sam will have to do.
While Sam's babies might not have the long necks that James' babies would have had, they'll be less noticeable to predators, and at least they'll have more sex appeal than Ben's babies. So, with predation, this is how the population might adapt. Natural selection is a balancing of many different environmental factors with many different physical traits of organisms. But natural selection is just one way populations evolve. Gene flow refers to the genetic additions or subtractions from a population resulting from the movement of fertile individuals or gametes. Gene flow is another way a population can evolve.
I don't know, Becky. Sam's okay, but hold your estrus, Patricia. Who is that?
Who, me? The name's Gene. I'm from the other population, and I came to spread my genes with a little bit of gene flow. But gene flow alone rarely causes a population to adapt. But wait, let's not forget about genetic drift. Genetic drift is a change in the gene pool of a population that takes place strictly by random chance alone. So in the case of a meteor shower,
Yes! Yes!
also, unlike natural selection, it does not cause a population to adapt. The next generation will not be more adapted to meteors falling on them. That was just a random event that changed our population's gene pool. Therefore, it evolves without adapting.
Thank you, genetic drift!
I think we just got bottlenecked.
Woohoo!
Yeah, and by the looks of it, we're
I
headed
almost
for
forgot.
extinction.
There's one more cause for evolution, and it's something that farmers and ranchers and animal breeders do for a living. Artificial selection is the selective breeding of domesticated plants and animals to encourage the occurrence of desirable traits. In other words, in artificial selection, we are the environment and we select the individuals who will make it to the next generation. You see these individuals when you cruise the produce section at your grocery store or your local pet shop. But do populations which evolve through artificial selection adapt? Take your little puppy and put him out in the Alaskan Arctic, and he probably won't fit in so well. Plop him on a sofa in front of a warm fireplace, however, and he will seem perfectly adapted. So yeah, sure, they adapt to us and the environments we create. We'll come back to the giraffes in a little bit, but for now, let's go into the laboratory so we can manipulate the environment to observe changes in a population under the microscope.